I want you to do something for me right now. Just take a second and look around the room you're sitting in.
Yeah, just take a real look.
Look at your computer, your phone,
Hmm.
the chair you're sitting on, or maybe the coffee mug that's, resting on your desk.
Right.
Take a good look at it. Now realize that a massive, totally invisible tax is just baked right into the price of every single one of those physical objects. I'm just talking about the cost of logistics.
It's something we completely take for granted, honestly. Like we look at a coffee mug and we just see ceramic and glaze.
Yeah.
We don't see the massive shipping container across the Pacific in, or the warehouse space it occupied in Ohio, or, the diesel fuel burned to get it to a local sorting facility.
Exactly.
And we definitely don't see the sheer human effort required to move those heavy atoms from a factory halfway across the world right to your front door.
And that effort, it isn't just some minor surcharge. It is a staggering multi-trillion-dollar tax on human civilization.
Oh, absolutely.
And it's a tax we basically just accepted as a permanent reality of physics and geography, right? We just assume that moving heavy physical things will always be chaotic and fragmented and really, really expensive.
Historically, well, yes, because physical reality is just stubborn. Atoms are heavy.
Right.
But the premise of what we are looking at today challenges that fundamental assumption. What if moving a physical product could become, as simple as programmable and as elastic as running a piece of software in the digital cloud?
And that question right there, that's the entire mission of our deep dive today. We are unpacking this genuinely visionary, and I have to say, incredibly dense manuscript.
Have you read? Yeah.
Yeah, it's titled Physical AWS, How the Logistics Cloud Will Reshape Global Commerce and Ignite the Age of Abundance, and it's by Paramendra Kumar Phagat.
A really fascinating text.
So we are going to explore this quiet but absolutely revolutionary shift happening right under our noses. I mean, we are transitioning from a world where companies have to build their own bespoke, incredibly fragile supply chains to a world where logistics just becomes a utility.
A utility is the perfect word for it, really. Think about it. When you turn on your faucet, you don't think about the reservoir or the purification plant or the miles of underground pipes.
So you just put glass under it.
You just expect water to come out. And Bhagat's manuscript argues that global commerce is moving toward that exact same model for physical goods.
Okay, so let's unpack this because the title of the manuscript itself is pretty provocative, right? Physical AWS.
Yeah.
The author isn't just using Amazon Web Services as a cute metaphor here. He's drawing this direct structural economic parallel to what happened to the internet 20 years ago. So to understand where the physical world is going, we kind of have to look back at what happened to the digital world.
Take me back to the early 2000s. How did AWS actually start? Because from what I understand, it wasn't supposed to be this world-eating product that runs half the internet.
Oh, not at all. It was actually an internal solution to a desperate, frankly, agonizing problem.
Really?
Yeah, back in the early 2000s, Amazon was growing at this breakneck pace. They were transitioning from just being bookstore into the everything store.
Right, I remember that era.
And they faced a classic infrastructure dilemma that was essentially choking their growth. Think about the holiday shopping season.
Yeah.
Black Friday, Cyber Monday, the whole lead up to Christmas.
Peak rush.
Exactly.
Yes.
Amazon needed enormous, totally unprecedented computing power to handle those massive, concentrated spikes in web traffic.
Because, if the site crashes on Black Friday, they don't just lose an hour of sales, they lose consumer trust.
Exactly.
People just click over to a competitor and maybe they never come back. Precisely. So to prevent that nightmare scenario, they had to go out and buy a staggering amount of physical servers to handle that peak demand.
Just massive rooms full of hardware.
Yeah, they had to build for the absolute maximum worst-case scenario traffic spike.
But, there's a huge flaw in that, right? Because for the other 10 months of the year, a massive chunk of those expensive, power-hungry servers are just, sitting there gathering dust in a data center.
It's the ultimate inefficiency. You either overbuild and waste tens of millions of dollars on idle hardware, or you underbuild and your website crashes when it matters most, which costs you tens of millions in lost revenue.
A lose-lose situation.
And, it wasn't just the physical hardware that was the problem, it was the internal bureaucracy, too.
How so?
Well, every time a software engineering team at Amazon wanted to launch a new feature or test a new product, they couldn't just do it. They had to submit a request to the IT department, beg for server space, and wait weeks for new hardware to be procured, delivered, and manually configured.
Oh, wow, that sounds awful.
It was artisanal, it was painfully, painfully slow.
Which is the exact opposite of how a fast-moving tech company wants to operate. So how did they actually fix it?
They decided to standardize the chaos. They built these internal tools to automate the provisioning of servers. So instead of hardware being this bespoke manual thing, they abstracted it.
Okay.
They broke their infrastructure down into modular, repeatable digital building blocks. A developer can just type a command and instantly have access to computing power without ever talking to an IT guy.
And then I guess the legendary aha moment happens, right?
Yeah.
Somebody looks around and realizes, wait a minute, every other internet startup and massive enterprise on planet Earth is dealing with this exact same nightmare.
That was the paradigm shift, yeah. They realized that infrastructure didn't just have to be an internal cost center. It could be a highly profitable external product.
And that was the birth of AWS.
Right. In 2006, they launched Amazon S3 for data storage and EC2 for computing power. And the impact, honestly, it was seismic.
I mean, it changed everything.
Before AWS, if you and I wanted to start a tech company, we had to go raise $1 million from venture capitalists just to buy physical servers to host our website.
Just to get through the door.
Exactly. After 2006, we didn't need to buy anything. We could just rent world-class, industrial-grade computing power by the hour using a personal credit card.
And the magic word that unlocked all of this, the term you hear everywhere in tech, is elasticity, the pay-as-you-go model.
Elasticity is everything. It means the infrastructure breathes with your business.
Breathes with it. I like that.
Yeah, so if your new app goes viral overnight, the cloud automatically spins up 1,000 new servers to handle the traffic. You don't crash.
Right.
And then, when the hype dies down 3 days later, it spins those servers right back down. You only pay for exactly what you used.
AWS basically made failure affordable. I mean, if our hypothetical startup completely tanked after a month, we just turned off the cloud instances.
Exactly.
We weren't stuck with a warehouse full of depreciating Dell servers that we had to auction off for pennies on the dollar.
No, you just walk away.
That elasticity is arguably the main catalyst that triggered the massive startup boom of the 2010s, right?
Yeah.
Like Uber, Airbnb, Netflix, they all scaled on this exact model.
It completely democratized scale. It allowed a couple of kids in a garage to access the exact same computing power as a Fortune 500 company. It turned massive capital expenditures, buying hardware, into manageable operational expenditures, just renting capacity.
Okay, I follow the history, and the analogy is brilliant. AWS is like realizing you don't need to build a bespoke coal power plant in your backyard just to turn on a reading light. You just plug into the shared municipal grid.
Perfect analogy.
But here's where I really have to push back on Fogat's core thesis.
Yeah.
Because data is weightless.
Sure.
A line of code traveling through a fiber optic cable doesn't care about a blizzard in Chicago. An email doesn't care about a labor strike at the port of Los Angeles. Things are heavy. Atoms are constrained by gravity, by geography, by the sheer physical friction of the real world. So does this digital cloud analogy actually hold up when we're talking about moving heavy physical goods across oceans and highways?
It's the most common critique of this entire concept, and frankly, it's the most important one to address.
Good. I'm glad I'm not the only one thinking it.
But Bagat argues that the fact that atoms are heavy and constrained is exactly why the analogy holds up, and why the financial opportunity is actually magnitudes larger than the digital cloud.
Wait, really? Magnitudes larger?
Yes. Because physical constraints exist, the baseline inefficiency in the real world is astronomically worse than it ever was in the digital world.
Walk me through that. Why does worse inefficiency equal a better opportunity?
Think about the fundamental bottleneck of modern commerce. The internet has evolved to generate demand instantly, right?
Yeah, a single viral video on TikTok can create 1 million orders for a specific cosmetic product overnight.
Exactly. The demand signal travels at the speed of light. But a traditional physical supply chain, it cannot respond instantly. It moves at the speed of cargo ships and forklifts.
Which is very slow.
It might take 3 months to source the raw materials, manufacture the product in Vietnam, load it onto an ocean freighter, clear customs in Long Beach, put it on a rail car to Memphis, and finally truck it to a local distributor.
So you have this massive 3-month gap between the consumer wanting the thing and the thing actually being available to give to them.
Exactly. And in that gap, you have lost sales, canceled orders, and just massive capital tied up in inventory sitting in transit.
Just floating on the ocean.
Fixing that mismatch, forcing the movement of heavy atoms to somehow respond to the speed of digital demand, that is the multi-trillion-dollar opportunity. The friction is so high that the entity capable of removing it will capture an unprecedented amount of value.
Which brings us to the core economic engine that Bhagat says makes this entire endeavor possible and profitable. He calls it the deflationary flywheel.
Yes, a critical concept.
I really want to spend some time on this because it feels like the secret sauce.
Yeah.
How does this flywheel actually work in the physical world?
So a flywheel, in business terms, is a self-reinforcing loop. In this context, it starts with scale. Imagine a logistics platform, let's just call it the physical cloud, that decides to handle shipping for not just one company, but thousands of companies simultaneously.
That's a massive scale.
Because they are handling massive volume, they generate an ocean of data.
Data about what, exactly? Just where packages are going?
Way more than that. Data about what specific demographics are buying, the seasonal demand curves of millions of products, the exact traffic patterns on Interstate 80 at 2:00 p.m. on a Tuesday, the turnaround times at specific ports, even local weather disruptions.
Oh, wow.
It's a highly granular, real-time map of global physical movement.
Okay, so they have a literal mountain of data. What does that actually do? Like, how does that save money?
That data is the food for artificial intelligence and predictive routing algorithms. And this is where the efficiency really kicks in. In a traditional supply chain, a truck might deliver a full load from Chicago to St. Louis. But then the driver can't find a load to take back, so they drive back to Chicago entirely empty.
That sounds like a terrible business model.
In the logistics industry, that's called deadhead miles, and it is a massive waste of fuel, time, and money.
Right, because nobody's paying you to drive an empty box down the highway.
Exactly. But the AI in the physical cloud, because it has visibility across thousands of different merchants' inventory needs, it perfectly coordinates the network.
How so?
It tells that driver in St. Louis, hey, go 3 miles down the road, pick up this pallet of electronics, and take it to the sortation center in Springfield on your way back.
So the empty miles just drop to near zero.
Yes, and warehouses aren't holding dead, unsold stock because the AI predicts demand and only positions inventory where it will actually sell.
And because they've eliminated all that waste, the empty trucks, the idle warehouse space, their operational costs just plummet.
Precisely. That massive increase in operational efficiency dramatically lowers the cost of moving the goods. Now, the platform takes those savings and passes a portion of them on to the customer in the form of much lower shipping prices.
And here comes the loop, right?
Yep.
When the platform lowers its prices, it becomes the most attractive option on the market. That attracts even more businesses who want cheaper shipping.
More businesses mean more volume.
More volume means even more data.
And more data makes the AI even smarter, which drives efficiency even higher, which lowers costs further, which attracts more customers. Round and round it goes.
That is the deflationary flywheel. It is an economic engine explicitly designed to compress costs relentlessly over time.
And we saw this exact same phenomenon with AWS in the digital realm.
We did.
Oh, yeah. Over its first decade, AWS proactively cut its prices dozens of times, not because a competitor forced them to, but because the flywheel made compute power cheaper to provide, and they wanted to capture more volume.
That's wild.
Bhagat argues that a mature physical cloud will do the exact same thing to the cost of trucking, ocean freight, and warehousing.
It's an incredible theory, and mathematically, I mean, it makes total sense. But if the economics translate from the digital world to the physical world, I want to literally open the hood.
Let's do it.
What does a physical cloud actually look like in the real world? Because we aren't talking about server racks anymore. Let's deconstruct the machine. How does this compare to how shipping works right now?
To really appreciate the machine, you have to understand the nightmare it's replacing. Let's look at traditional third-party logistics, commonly known as 3PLs.
Okay, 3PLs.
You have these legacy companies offering to move goods, but the traditional 3PL model is highly fragmented and incredibly bespoke.
Let's use a real-world example to kind of ground this. Imagine I'm an independent creator based in Ohio, right?
Yeah.
And I've engineered a fantastic high-end coffee grinder.
Sounds like a great product.
Thanks. I want to sell it globally. If I use the traditional 3PL system, what does my life look like?
It looks like a lot of paperwork, a lot of emails, and a lot of frantic phone calls.
Look right.
First, you have to find a freight forwarder in China to get your manufactured grinders onto an ocean vessel.
Okay.
Then you have to hire a completely separate customs broker to deal with the import duties when it hits the U.S. port.
Right.
Then you negotiate a manual, long-term contract with a warehousing company in the Midwest to store your pallets. You have to commit to minimum volumes, maybe sign a 3-year lease on warehouse space.
Which is a ton of upfront capital.
Exactly. And finally, you integrate yet another separate parcel delivery service like FedEx or UPS to pick up the individual orders from that warehouse and take them to your customers.
And let me guess, none of these companies naturally talk to each other.
Not at all.
Their software systems are totally different. So if my ocean freighter gets delayed by a massive storm in the Pacific, the warehouse in Ohio doesn't automatically know.
Nope.
I have to call them, apologize, and maybe pay a penalty because my containers didn't show up for their scheduled unloading time. It's incredibly brittle.
It is entirely reliant on human intervention to bridge the gaps between these isolated silos. Compare that to the architecture of the physical cloud, which Pagott models heavily on Amazon Supply Chain Services, or ASCS.
Okay, so how is ASCS different?
The goal here is full stack, multi-tenant integration.
Multi-tenant, that's another classic cloud computing term. Break that down for us in a physical sense.
Sure. In digital cloud computing, multi-tenant means that a single physical server in a data center is simultaneously hosting the websites of a dozen different companies.
Right, they all share the hardware.
Exactly. They share the exact same underlying hardware, separated and secured only by software. In the physical cloud, you don't rent your own dedicated bespoke warehouse in Ohio.
So where do my coffee grinders go?
You share cubic space in a massive, hyper-optimized network of facilities alongside thousands of other merchants. Your coffee grinders might be sitting on a shelf right next to someone else's dog toys and another company's winter coats.
Okay, let's map out this full stack, layer by layer. Because Pagott actually translates physical logistics assets into their digital cloud equivalents, and I think it's a fascinating way to look at it.
It really clarifies the concept.
At the very foundation, at the bottom of the stack, you have freight. He calls these the arteries of the physical cloud.
Right. Think about the digital cloud. You have different connection speeds and storage tiers based on how fast you need your data and how much you're willing to pay.
Right.
In the physical cloud, you have different modes of freight. Air freight is your premium high-speed compute instance.
Because planes are fast but expensive.
Exactly. It is incredibly expensive per pound, but if you have a highly profitable item or an urgent, unexpected spike in demand, you spin up air cargo to bypass the slow lanes.
And on the opposite end of the spectrum, you have ocean freight.
Ocean freight is like archival data storage, think AWS S3 Glacier.
Ah, right.
It is agonizingly slow, taking weeks to cross the Pacific, but it is unimaginably cheap for moving massive bulk volumes of inventory that you don't need tomorrow.
And sitting between those extremes, you have rail networks and ground transport, right?
Yeah, which act as your general purpose workhorses, steadily moving volume between regional hubs.
So the goods move through these freight arteries, and they arrive at the fulfillment centers. And this is honestly my favorite analogy in the book. He calls these fulfillment centers the data centers of the physical economy.
Yeah, it's a perfect description.
Because they aren't just big, dumb, empty metal sheds where boxes sit on metal racks gathering dust.
Far from it. They are dynamic compute nodes where the logic of commerce is physically executed.
What does that mean, physically executed?
Well, in a digital cloud like AWS, a smart developer doesn't put all their code in one single data center in Virginia.
Right, that's too risky.
They distribute their application across multiple data centers globally. That way, if a hurricane takes out the Virginia facility, the app stays online, and more importantly, it reduces latency.
So a user in Tokyo connects to the Tokyo data center, not the Virginia one, so the app loads faster.
Exactly. And the physical cloud does the exact same thing with physical inventory.
That is wild.
When your container of coffee grinders enters the physical cloud, the AI doesn't just dump them all in one giant warehouse in Ohio.
What does it do?
It looks at historical data and says, okay, 20% of the demand for this grinder comes from California, 15% from New York, 10% from Texas. It automatically breaks down your pallets and dynamically distributes your inventory across dozens of regional fulfillment centers.
So my product is physically sitting closer to the eventual buyer before that buyer even clicks purchase.
Yes.
That is how they eliminate the tyranny of distance.
Yes. And between those fulfillment centers and the final customer, you have the distribution and sortation centers. These are the hidden routers of the physical cloud.
Like a Wi-Fi router.
Sort of. Their job is load balancing. If that fulfillment center in Ohio gets slammed with a massive spike in regional orders and starts backing up, the sortation layer software instantly recognizes the bottleneck.
Oh.
It reroutes subsequent orders to a facility in Indiana that has spare capacity, dynamically balancing the network traffic to prevent a catastrophic backlog.
And finally, at the very tip of the spear, you hit last mile delivery. The text equates this to edge computing.
Right. In the tech world, edge computing means pushing the data processing out of the centralized data center and putting it as close to the user's device as possible.
Like on a local cell tower or even on the phone itself.
Exactly, to eliminate the last few milliseconds of lag. In logistics, the last mile network, the delivery vans, the cargo bikes, the local neighborhood delivery stations, that is the edge.
So by bringing the inventory to the absolute edge of the network, you eliminate physical latency.
Yes, that is the structural secret to achieving reliable same-day or even sub-2-hour delivery.
Okay, I see the hardware stack, I really do. But having planes, warehouses, and vans isn't what makes it a cloud. I mean, UPS and FedEx have had planes and vans for decades. The most crucial part of this entire manuscript, the thing that completely broke my brain, is the interface. It's what he calls the logistics console and the APIs.
This is the game changer.
Because making logistics programmable changes the fundamental nature of the industry. It means supply chain management stops being a relationship business of who you know and actually becomes software engineering.
I agree completely. This is the crux of the revolution. The real innovation isn't the physical warehouses or the diesel trucks. It's the orchestration layer.
The software.
Yes. It's the software that dynamically manages and allocates physical shipments across that vast infrastructure, exactly like AWS allocates digital workloads across millions of servers.
We use the term API a lot, application programming interface. For a listener who isn't a software developer, how should they visualize what an API actually does in the context of moving a physical box?
Think of an API as a digital universal translator and an authorized messenger. Remember the nightmare of the traditional 3PL? Your warehouse software in Ohio couldn't talk to the ocean freight software in China because they spoke different digital languages.
Right.
An API bridges that gap. It allows two completely different computer systems to talk to each other seamlessly, securely, and instantly without a human ever picking up a phone.
So, in the old world, a logistics manager was literally sitting at a desk, looking at an Excel spreadsheet, calling a trucking company, tracking down physical bills of lading, and, yelling at freight forwarders over email to figure out where a container was.
Right. It was manual, slow, and incredibly error-prone. In the new physical cloud model, a junior software developer at your coffee grinder company can write a simple script of code.
Just a few lines of code.
Exactly. That code says if our inventory of grinders in the Northeast region drops below 500 units, automatically trigger an API call.
And what happens then?
That single line of code speaks to the physical cloud's console. The cloud automatically initiates an ocean freight shipment from your factory in Shenzhen, dynamically routes it around a port strike in Seattle, clears customs digitally via another API, and slots it into the Pennsylvania fulfillment center.
That is insane.
The developer wrote a few lines of logic, and thousands of pounds of steel and electronics moved across the globe entirely automatically.
It reminds me of an analogy. Imagine an old-school restaurant kitchen. Every time a new chef wants to start a pop-up restaurant, they have to bring their own physical stove, build their own prep tables, source their own meat and vegetables from different farmers, and hire their own dishwashers.
It's incredibly capital-intensive and chaotic. That's the bespoke 3PL supply chain.
Exactly. The physical AWS is like walking into a massive, hyper-advanced, fully automated shared kitchen facility.
A great analogy.
You don't build the kitchen. You don't source the ingredients. You just upload your recipe, which is your API call. The system automatically sources the exact ingredients, cooks the meal to your exact mathematical specifications, and delivers it to the customer's table.
Right.
You, as a creator, focus entirely on the recipe, the design and marketing of your product. The platform handles 100% of the execution.
That abstraction of complexity is exactly what happens when you put physical infrastructure behind a digital API. You hide the messy reality of the real world behind a clean line of code.
It's elegant.
But this brings us to the core mechanism that makes that automated kitchen actually function. Because human brains, no matter how smart, simply cannot optimize millions of dynamic, unpredictable moving parts simultaneously.
No, we just don't have the processing power.
The hardware stack is impressive, sure, but we have to look at the software brain running it, physical AI.
Right, because if you're going to relentlessly compress the cost of logistics, like the flywheel demands, you have to tackle the biggest expenses in the system. And historically, the biggest expenses are human labor and human error.
Absolutely.
The book details how physical AI is shifting warehouses away from a manual labor model to what he calls a factory model of fulfillment. We're talking about heavy automation here.
The operational shift is profound. Visualize a traditional warehouse for a second.
Okay.
It's essentially a massive library. When an order comes in, a human being receives a piece of paper or maybe a scan gun, and they walk.
It's just walking down aisles.
They walk miles and miles every single shift, pushing a heavy cart, navigating aisles, visually scanning shelves for the right barcode, grabbing the item, and walking it all the way back to a packing station.
It's incredibly inefficient.
Mm-hmm.
I mean, the human is spending 80% of their time just walking, not actually picking the product.
Exactly. It is wasted motion. In a robot-powered warehouse like the Kiva systems, Amazon employs the paradigm is completely inverted. The human doesn't walk to the shelf. The shelf drives to the human.
Oh, wow.
Hundreds of low-profile autonomous robots scurry around the floor, lift entire vertical racks of inventory, and bring them exactly to the human packer's station. The human stands still and simply reaches out. It virtually eliminates wasted motion.
And it allows the warehouse to be packed much denser.
Yeah.
Right, because you don't need wide aisles for humans to walk down safely.
Precisely. You maximize the cubic volume of the building. And, the AI isn't just inside the warehouse.
Right.
When you apply predictive routing to the delivery vans, AI looking at historical traffic congestion at specific intersections, real-time weather patterns, and the exact dimensional size of the packages, it calculates the absolute mathematically perfect path for that van.
So no left turns, that kind of thing.
Exactly. You eliminate wasted time, you save massive amounts of diesel fuel, and you significantly increase the number of stops a driver can make in a single shift.
Okay, I hear all of this,
Yeah.
but here is where I get highly skeptical.
Okay, lay it on me.
The book paints this picture of full automation. Drones dropping packages from the sky into our backyards, sleek self-driving big rigs zooming down the highway while the driver sleeps in the back.
Yeah.
I feel like we've been promised that these things are, 5 years away for the last 15 years. Are we just buying into Silicon Valley tech hype here? Is this actually happening, or is it science fiction?
It's a vital question to ask, and to Pagat's credit, he doesn't shy away from that reality at all.
Good.
Full Level 5 autonomy on public roads faces massive, potentially intractable regulatory, legal, and safety hurdles.
Right, it's a legal nightmare.
We are not going to see completely driverless 80,000-pound trucks dominating public highways tomorrow. But
Yeah.
the crucial insight here is that the AI doesn't need to drive the physical truck to be revolutionary today.
Wait, what do you mean? How does it save money if it's not actually driving the truck?
Because the intelligence of the system is already mature and actively deployed, the internal warehouse robotics, the automated sorting arms, the self-navigating inventory pods we just talked about, those are actively compressing costs inside the four walls of the fulfillment center right now.
Okay, that makes sense.
Furthermore, the predictive routing algorithms don't need to physically turn the steering wheel of the delivery van. They just need to tell the human driver the mathematically perfect route to take.
Ah, I see. So the human is just following the AI's optimized instructions.
Exactly. And even more importantly, the AI knows exactly how to pack that truck.
Oh, like 3D Tetris.
Yes. It plays a perfect game of 3D Tetris, telling the loaders exactly which box goes where in what precise sequence to maximize every single cubic inch of the trailer while ensuring that the packages to be delivered first are loaded last.
That is brilliant.
The optimization of the physical space and the mathematical routing is where the immediate deflationary magic happens. The brain of the operation is already here, generating massive savings long before the robot ever takes the driver's seat.
So the software is already doing all the heavy lifting of optimization, while humans basically act as the physical actuators for now. That makes a lot of sense. So if this hyper-efficient, AI-driven, programmable network is coming online, the next logical question is, who actually gets to use it?
Everyone, eventually.
Let's move from the theory to the real-world beneficiaries.
The impact scales across every conceivable level of business, but it really starts with a massive democratization of commerce for what we call SMEs, small and medium enterprises, and solo entrepreneurs.
This connects back to our coffee grinder example earlier. This is the rise of the global micro brand.
Yes.
Before, if I had a genius idea for a physical product, the logistics would literally ruin me. I could maybe scrape together the funds to get a prototype manufactured in China, but fulfilling global orders out of my garage.
It would be impossible.
Shipping costs alone would eat all my margins.
Yeah.
And the first time I had to deal with a European customs hold, my entire business would fold.
The barrier to entry in the physical world was capital and complexity. With a physical AWS, that barrier just vanishes.
It's gone.
A single person with a laptop sitting in a coffee shop can orchestrate a global, synchronized physical product launch across North America, Europe, and Asia, without ever signing a lease for a single warehouse or hiring a logistics manager.
Exactly. Just as AWS allowed two broke developers to build a globally scalable software company over the weekend, the logistics cloud allows one creative person to build a global physical brand.
It's incredibly empowering.
But it's not just for the solo entrepreneur in the garage. Let's look at mid-market companies. Businesses doing maybe 50 to 500 million in revenue. For them, this isn't just about starting up. It's a scaling engine.
For a mid-market company, their logistics bottleneck is almost always their primary constraint on growth.
How so?
Let's say a successful U.S. apparel brand suddenly sees massive organic demand in Germany. Under the old model, they can't afford the capital expenditure to build a dedicated European distribution center.
Well, that's millions of dollars.
So they ship individual orders across the Atlantic, which takes weeks and costs an absolute fortune in shipping, eventually killing the European demand because the customer experience is terrible.
They just get frustrated and stop buying.
Exactly. But by plugging into the physical cloud, they escape that capital expenditure trap. They instantly spin up physical fulfillment capacity in Germany via an API call. They scale their physical footprint globally instantly without pouring a single yard of concrete.
Okay, it makes total sense why a solo creator or a mid-market brand desperately needs this. But let me challenge this from the top end.
Okay.
What about the absolute giants, the Fortune 500? Why would a massive multinational corporation like Procter & Gamble or 3M, who already have massive global supply chains that they've spent decades building, why would they ever hand over their logistics to a third-party cloud platform? Wouldn't they just keep doing it themselves to maintain total control?
It's completely counterintuitive until you look at the reality of how enterprise supply chains are actually built.
Okay, enlighten me.
The text points out a critical vulnerability of large enterprises. Their supply chains are often a terribly fragmented mess of legacy systems.
Because of mergers and acquisitions.
Exactly. A giant like P&G doesn't grow purely organically. They buy dozens of other companies over the decades.
And they inherit all their junk.
Yes. Every time they buy a company, they inherit that company's outdated warehouses, their ancient software systems, their unique trucking contracts.
Oh, man.
So you have a Fortune 500 giant where the European division is using warehouse management software from 2004, and the Asian division is using a completely different, totally incompatible system. They are massive, but they are incredibly rigid and brittle.
So they can't adapt quickly.
They cannot. The Fortune 500 will adopt the physical cloud for what Pagat calls the fortune of flexibility. They will move toward hybrid resilience models.
Well, they won't just sell all their warehouses.
No, they won't abandon their own massive warehouses entirely. They have way too much invested, but they will plug into the logistics cloud to act as a pressure valve.
Ah, I see.
If they have an unexpected peak season or a strike at one of their legacy facilities, they seamlessly overflow that volume into the physical cloud. It provides instant, programmable redundancy that their legacy systems physically cannot achieve.
I want to ground this in some concrete scenarios because otherwise it stays a bit too theoretical. Let's explore some real-world situations where this programmable supply chain mathematically prevents a total disaster.
Okay, let's hear one.
Say I'm that indie creator in Ohio, and my high-end coffee grinder suddenly gets featured by a massive influencer on TikTok. Millions of views.
Under a traditional supply chain, that viral moment is actually a catastrophe.
A catastrophe.
Yes, it's what we call flash demand.
Yeah.
You might get 50,000 orders in 3 hours. Your bespoke warehouse in Ohio has 5 employees. They can physically only pack 500 boxes a day.
Oh, right.
Your website stays online because it's hosted on AWS, but your physical fulfillment pipeline collapses. Customers who bought the grinder won't get it for 2 months. They get angry, they do chargebacks on their credit cards, and your brand reputation is destroyed by your own success.
The physical infrastructure choked. But if I'm running on the physical cloud,
The physical cloud absorbs that flash demand elastically. Because you are sharing infrastructure with thousands of other companies, the facility has hundreds of workers and advanced robotics.
Seems like.
The system recognizes the massive spike in your API calls, dynamically reallocates robotic picking arms and human labor to your specific SKUs for that shift, and ships all 50,000 grinders within 48 hours.
That is incredible.
The shared infrastructure scales its physical compute to handle your localized spike.
And what if I want to offer an insane customer experience, like same-day delivery for that grinder? How does the cloud achieve that without me bleeding money on expedited air shipping?
That's the power of hyper-local fulfillment, pushing inventory to the edge.
Right, the edge computing analogy.
The platform's AI looks at the aggregate data and realizes, hey, there is a massive concentrated demand for this specific coffee grinder in the north side of Chicago.
Before anyone even orders it.
Yes, before those customers even click buy. The AI routinely moves a pallet of grinders from a central hub into a micro-fulfillment center, maybe the size of a grocery store, right in that specific Chicago neighborhood.
So we're already there.
When the customer finally orders it, the physical latency is only 3 miles. A local driver drops it off in 2 hours. You offered ultra-premium delivery speed while paying standard local ground shipping rates.
Okay, let's look at another scenario, specifically for manufacturing. The book talks a lot about just-in-time precision and how the pandemic exposed how incredibly fragile that concept is.
Just-in-time, or JIT, manufacturing is an efficiency philosophy where a car company, for example, tries to hold zero inventory of spare parts.
Not at all.
They want the steering wheels to arrive from the supplier exactly 3 hours before they are bolted onto the car on the assembly line. It saves millions in warehousing costs.
But as we saw during the pandemic, if one single cargo ship gets stuck in the Suez Canal or one port shuts down, the entire assembly line grinds to a halt because there is no buffer stock. It's perfectly efficient, but perfectly fragile.
Precisely. The physical cloud brings resilience back to JIT manufacturing through total API visibility.
How does visibility fix the Suez Canal?
Because the platform controls the end-to-end movement, the manufacturer's software knows the exact GPS coordinates and transit status of every single component globally in real time.
Okay.
If the AI detects that a port in Taiwan is backing up, it doesn't wait for the delay to happen. The orchestration software automatically triggers a contingency. It pulls a batch of critical microchips off the ocean route, pays the premium to reroute them onto an air freight instance, and flies them to the factory just in time to keep the line running.
The software dynamically patches the physical supply chain in real time. That is wild.
It is.
Which brings us to the macroeconomic scale of all this. We've talked about how this empowers individuals and giant corporations, but I want to look at the map of the world. How does a global logistics cloud change the wealth and participation of entire developing nations?
It's a profound shift.
Because historically, geography has been destiny. If your country is landlocked or lacks a robust national trucking network, you are largely locked out of global trade.
Fagot suggests a massive macroeconomic phenomenon of leapfrogging. To understand this, look at the history of telecommunications in the developing world, particularly in parts of Africa and Southeast Asia.
Okay.
Many of these regions never went through the incredibly expensive multi-decade process of laying copper wire across the entire country for landline telephones.
Right. It was too capital intensive, too slow, and totally prone to theft or damage.
Exactly. So what did they do? They skipped a whole generation of infrastructure. They went straight from having basically no phones to building cellular towers, leapfrogging directly into the mobile internet era.
And Fagot posits that emerging markets could do the exact same thing with physical logistics.
Yes. Instead of a developing nation spending 50 years trying to build a bespoke, highly fragmented domestic 3PL network, fighting through layers of corrupt local middlemen and inefficient freight forwarders, local businesses could simply plug their exports directly into a global logistics cloud platform.
So an artisan cooperative in rural Kenya could list their goods via an API.
And the global platform handles the international freight, customs, and final delivery to a buyer in London. It integrates them instantly into the global trade network, entirely bypassing local inefficiencies.
Okay, but here's the brutal reality check, and I really have to point this out, because as much as we love software, you cannot deploy an API to a dirt road.
Very true.
Software doesn't fill potholes. Software doesn't dredge deep water ports so massive container ships can dock. There is a massive, unavoidable infrastructure gap. A logistics cloud, no matter how smart the AI is, still requires a massive physical foundation of concrete and steel to sit on.
It's a sobering and vital point, and an entire chapter of the book is actually dedicated to it.
I'm glad he didn't ignore it.
For a physical AWS to truly globalize and offer low-latency delivery everywhere, there has to be a physical construction boom on a scale we haven't seen since the post-World War II era.
We're talking massive public works.
We need paved, all-weather roads to support the last-mile edge network. We need modern, high-speed rail corridors to act as the low-cost bulk freight backbone. We need highly automated deep-water ports. And crucially, all of these robotic fulfillment centers we talked about require massive, incredibly reliable, uninterrupted electrical grids.
Right. A robot warehouse is totally useless if the local grid suffers rolling blackouts.
Exactly.
So how does that actually get built? I mean, Amazon or whoever builds this cloud is not going to step in and pave the national highway system of an entire emerging economy. They are a software and logistics company, not a nation state.
No, they aren't. And this is where the financing of the future becomes complex. It requires public-private partnerships, or PPPs, and specifically what the financial world calls blended finance.
Explain blended finance for us. What does that actually mean in practice?
Imagine a massive infrastructure project in a developing nation, say, $1 billion automated port facility and rail link. Private capital, like Wall Street investors or the logistics platform itself, might look at that country and say, it's too risky, the political situation is unstable, the currency fluctuates, we won't invest.
Which happens all the time.
Blended finance uses public or philanthropic money to absorb the riskiest part of the deal. Institutions like the World Bank or regional development funds step in and provide concessional funding.
Concessional funding meaning loans with super low interest rates or longer payback periods than a normal bank would ever offer.
Exactly. Or even outright guarantees. The World Bank might say to the private investors, if this project fails due to political instability, we will cover 30% of your losses.
Oh.
By using public money to de-risk the project, it suddenly makes the math work for the private capital to flood in. So the government provides the land and uses blended finance to build the roads and the power grid.
And the company brings the tech.
Then, the private logistics platform brings in the robotics, the AI software, and the operational expertise. They share the risk, and they share the upside.
And if they manage to pull that off and actually build this global physical network, you end up with a profound shift in who actually makes money in global trade.
It raises a fundamental economic question. If the barriers to logistics drop to near zero, who captures the value?
Right.
Historically, the people who controlled the logistics, the wholesale distributors, the import-export middlemen, the shipping cartels, they captured a massive, totally disproportionate share of global wealth.
Because they controlled access to the consumer market.
Exactly. A farmer producing coffee beans saw pennies, while the middleman who navigated the complex shipping and distribution saw the dollars.
Because the friction was their moat.
Exactly. But if logistics becomes a cheap, transparent, universally accessible software utility, that moat just evaporates. The wealth inevitably shifts away from the middlemen and distributors and flows back toward the actual creators, the artisans, the original producers, and the end consumers.
It is a massive decentralization of wealth creation.
It truly is.
Okay, but whenever we talk about wealth shifting and middlemen being cut out, we have to talk about the human cost. We can't just gloss over the disruption. Because right now, millions of people make their living as those exact middlemen.
Millions.
Millions of people work as manual warehouse pickers or long-haul truck drivers or customs clerks. What happens to them when the automated kitchen takes over?
We have to unpack the harsh reality of labor displacement. The transition to a highly automated AI-driven logistics cloud is going to be incredibly painful for traditional blue-collar logistics workers.
It's unavoidable.
As fulfillment centers fully shift to that Kiva robotics model, the demand for human beings whose only job is to walk and carry boxes will plummet drastically. As predictive routing and highway autonomy mature, the nature of truck driving will change, likely reducing the need for long-haul drivers.
I think about the local delivery drivers in my own neighborhood, the folks driving the step vans, dropping boxes on porches. Does their job disappear entirely?
The last-mile delivery driver is actually one of the hardest jobs to fully automate because walking up a snowy driveway, opening a gate, and avoiding a dog is incredibly complex for a robot.
That makes sense.
But their jobs will be heavily augmented and micromanaged by the AI. However, the text points out that overall, the jobs don't just vanish. They transform into what he calls the new skill economy.
Right, the transition from manual laborer to supply chain engineer.
Correct. The robot warehouse still needs humans, but different kinds of humans. We will need massive fleets of robotic supervisors, electromechanical technicians who repair the drones, and Kiva bots when they break down, and data analysts who monitor the logistics consoles to ensure the APIs are firing correctly.
It's a completely different skill set.
The daily work becomes significantly less physically backbreaking, but it requires a much, much higher technical baseline. It forces a massive societal-level retraining effort that governments are currently completely unprepared for.
And the economic trade-off for that massive labor disruption is what Bhagat calls the deflationary impact. We talked about logistics being an invisible tax. The macroeconomic theory here is that if the physical cloud's flywheel relentlessly drives down the cost of shipping, warehousing, and inventory management, the cost of the actual goods sitting on the shelves plummets too.
Everything gets cheaper to buy because it's cheaper to move. Groceries, medicine, consumer electronics, building materials.
Hey.
If 20% of a product's retail price is just the baked-in cost of a highly inefficient supply chain, and you wipe out that inefficiency, the overall cost of living drops.
Which leads directly to the philosophical endpoint of the entire manuscript, the abundance hypothesis. The digital world achieved abundance decades ago. The marginal cost to stream a song on Spotify or copy a PDF file is practically zero. It costs nothing to duplicate bits.
Yeah.
Can the physical world achieve that same level of abundance?
We will never hit absolute zero in the physical world. Bits are weightless, atoms have mass.
Gravity always wins.
Moving a physical object will always require energy, whether that's electricity from a solar panel or diesel in a tank. But the abundance hypothesis argues that if we compress the structural inefficiencies enough through AI and multi-tenant scaling, physical goods could become so cheap to distribute that they become universally accessible.
A beautiful thought.
We move closer to an era of baseline material abundance for everyone.
So let's bring this back to you, the listener. What does all of this actually mean for your daily life? It means that over the next decade, the physical things you buy could get significantly cheaper. Your delivery times will compress from days down to hours.
A universe of global products will be instantly at your fingertips.
But the societal trade-off is a massive, painful structural reorganization of the blue-collar job market. It's the classic double-edged sword of technological progress. We get the fruits of abundance, but society has to figure out how to navigate the human displacement.
And that very displacement, combined with the sheer, unimaginable economic power of the platform itself, leads to inevitable conflict. A system this powerful does not get built without a fight.
Which brings us to the geopolitical and corporate battlefield: rivals, regulation, and geopolitics. If a physical AWS is going to effectively govern the cost of living and route the flow of global trade, governments and massive corporate competitors aren't just going to sit back and let one single tech company own the operating system of the physical world.
Absolutely not. The battle to become the dominant logistics cloud is going to be the defining corporate war of the next 20 years.
Who are the main players?
First, you have the legacy incumbents, the traditional 3PLs like UPS, FedEx, Maersk, and DHL.
They already have the assets.
They have a massive head start on physical assets, the planes, the trucks, the global sorting hubs. But historically, they severely lack the deep, native, API-driven software DNA required to build a true multi-tenant, developer-friendly tech platform.
Moving boxes is in their blood. Writing world-class orchestration code is not.
Exactly. Then you have the retail giants, Walmart in the US, Alibaba and JD.com in Asia. They have massive physical footprints and enormous daily volume. They will absolutely attempt to build competing physical clouds, opening their internal logistics networks up to third-party sellers just to deny Amazon a monopoly.
And beyond the corporate knife fight, you face massive existential antitrust questions. There's a deeply inherent conflict of interest when the company that owns the underlying platform is also a direct retail competitor on that exact same platform.
This is a huge issue.
Explain that dynamic a bit more.
Let's go back to your independent coffee grinder company. You are using the physical cloud to fulfill all your orders. The platform has perfect visibility into your data.
Right.
They know exactly how many units you sell, in what zip codes, at what price point, and what your return rate is.
They know everything about my business.
So what happens if the company that owns the cloud decides to launch their own cheaper private label coffee grinder using your data to perfectly target your best customers?
Regulators would have an absolute field day with that.
They will. Regulators will intensely scrutinize whether the platform is prioritizing its own goods in the sorting centers or algorithmically hiding competitors. We will likely see intense legal pushes for vertical integration to be broken up.
Like breaking up Standard Oil.
Governments might demand structural separation, forcing the logistics network to be spun off into a completely separate, independent company from the retail operation just to ensure a level playing field.
And then we step onto the global stage, national security and sovereign supply chains.
Mm.
Now, I want to be very clear here to our listeners. We are going to impartially report on the geopolitical reality described in the sources, taking no political sides. We are just looking at the mechanics of national power.
Understood.
The text details how governments globally are increasingly viewing supply chains not just as commercial operations for businesses, but as critical, strategic national assets.
The pandemic, followed by recent geopolitical conflicts, revealed the terrifying risks of having a single point of failure in global supply chains. Governments are deeply concerned about dependency.
Right, if you rely entirely on another country for your stuff.
If a hostile nation, or even just a localized natural disaster, disrupts a critical node in a globalized logistics cloud, the domestic economy halts. Hospitals run out of basic medical supplies. Factories shut down because they lack a specific microchip.
Furthermore, if the entire physical movement of goods is orchestrated by centralized software, there is the massive risk of cyber sabotage. You don't need to bomb a port if you can just hack the API that tells the automated cranes which containers to move.
Exactly. Paralyzing the software paralyzes physical trade.
Because of these vulnerabilities, the sources outline a major geopolitical trend called friendshoring, or supply chain regionalization.
Yes, a very real trend.
This is a movement where nations actively use tariffs and subsidies to encourage critical supply chains to be routed primarily through allied nations, rather than relying on hyper-efficient global networks that pass through adversarial territories. Governments are actively intervening to restrict where critical technology can go and demanding that vital goods like semiconductors, pharmaceuticals, or energy components be manufactured and stored domestically or within friendly borders.
They are actively choosing national security and resilience over pure economic efficiency. What's fascinating here is the paradigm shift. Logistics is shifting from being viewed merely as a commercial service like a taxi to being viewed as critical national infrastructure. Because of these intense national security and antitrust concerns, Pagat concludes that it is highly probable we will see these logistics platforms heavily regulated by the state, much like how we regulate power grids, telecommunications networks, or public utilities today.
It's the ultimate validation of the platform's power, really. When a government decides your company is too important to fail and too powerful to run without strict oversight, you have officially become civilization-level infrastructure.
Absolutely.
Which brings us to the final vision of the manuscript. Let's move past the regulatory battles and the infrastructure headaches. I want you to paint the picture of the ultimate end state described in the final chapter. Where does this all logically conclude?
The end state Bhagat describes is called the Great Convergence. It's the ultimate merging of the three fundamental networks of modern society: computing, logistics, and energy.
The Great Convergence.
Okay. In this future vision, warehouses are no longer just storage sheds. They become the new industrial nodes of civilization. Imagine a massive hyper-local fulfillment center. It has acres of advanced solar arrays on the roof generating massive amounts of power.
Okay.
Inside, it has industrial-scale battery storage. It houses mini data centers processing local edge computing for the neighborhood.
So it generates its own power, processes its own digital data, and orchestrates the physical movement of its own goods.
Yes.
The three networks become one single, orchestrated, self-sustaining system.
Yes. And the existence of this ubiquitous, instant, hyper-local physical cloud creates what the text calls the physical streaming economy. This is a concept that completely flips how human beings think about owning physical things.
I love this idea. Walk us through it.
Think about media. 20 years ago, if you wanted to watch a movie, you drove to a store, bought a physical DVD, and stored it on a shelf in your living room forever, even if you only watched it once.
Right, I have boxes of them in my attic.
Today, you don't own the movie. You just summon it on demand via a streaming service, watch it, and banish it back to the cloud. Haggad argues that a hyper-fast logistics network allows us to stream physical objects in the exact same way.
So if I'm doing a home repair project on a Saturday, instead of driving to a hardware store, buying a $200 power drill, using it for 20 minutes, and then letting it sit in my garage, gathering dust 364 days a year.
You don't buy the drill, you just pull out your phone and ping the local edge node via an API. A localized drone drops the drill on your driveway in 10 minutes.
Wow.
You use it for your project, you put it back outside, and the drone retrieves it, sending it back into the automated cloud to be streamed to the next neighbor who needs it.
It shifts the entire basis of society from an economy of individual ownership to an economy of instant access.
If we connect this to the biggest possible picture, the final overarching vision of the text is a fully programmable economy. Physical resources, inventory, heavy tools, critical medical supplies, emergency food are allocated dynamically. The AI anticipates human needs through aggregate data and moves physical atoms with zero friction. Civilization essentially begins to update and move itself like software.
It is a breathtaking, almost dizzying vision of the future. Let's take a breath and summarize the massive journey we've taken in this deep dive.
It's been a long journey.
We started with the origins of AWS, learning how Amazon's internal struggles with holiday web traffic gave birth to the digital cloud. We saw how that exact same concept of elasticity, the pay-as-you-go model, is now being aggressively applied to heavy physical atoms.
We opened the hood of this physical cloud, seeing how air freight, ocean liners, robot-powered fulfillment centers, and localized edge networks are tied together by universal APIs and orchestrated by physical AI. We saw how this deflationary flywheel removes the friction of distance, driving down costs exponentially.
We explored how this reshapes the business world, empowering a solo creator in their garage to launch a global brand, while allowing Fortune 500 giants to bypass their own legacy spaghetti code supply chains. We confronted the hard, physical realities of the infrastructure gap in emerging markets, the very real, painful displacement of human labor, and the geopolitical battles that will inevitably treat these platforms as critical, regulated national utilities.
So much to think about.
So the next time you're sitting at your desk, looking at that coffee mug, and you click buy on your phone, and a package miraculously appears on your doorstep a few hours later, realize what is actually happening behind the scenes. You aren't just experiencing good customer service from a retailer. You are interacting with the very early nascent stages of a programmable physical cloud. You're watching a system power up that will fundamentally reshape the geography, the wealth, and the daily reality of human civilization.
It's just the beginning.
We've talked extensively today about how this physical AWS will make everything faster, cheaper, and universally accessible. We've mapped out the mechanics of this coming age of abundance. But I'll leave you with this single thought to mull over on your own. If absolute efficiency, programmable perfection, and instant gratification become the default, invisible background noise of daily life, does the value of friction suddenly skyrocket? In a future where absolutely anything can be manufactured globally and shipped to your door instantly by a robot, maybe the ultimate untouchable luxury status symbol won't be speed or perfection. Maybe the highest status symbol of the future will be things that are slow, local, highly inefficient, and made entirely by flawed human hands. Something to think about.